really probably going to do long division stuff. Anything other than that, you probably aren't. Okay? You probably are just going to stick with other methods to divide. Alright, so just for an example, okay, just to remind you how these go. Alright? Not that big. You really want to write that down.
We don't need to know that. What?
Okay?
Should we just write this down?
No. One, I wouldn't. I wouldn't.
Okay, I just listened to you. I was like, let me listen. Like,
I'll go back to it in a second. Calm down. Alright, so here's the thing.
Yeah, really interesting.
With long division, okay? First thing, make sure you write it properly. That's on the outside. And then when you write this out, remember, do it as such that you're taking into account every term that would be there. Obviously, the function you're going to divide, the x to the fourth minus 4x squared, is missing a few terms. Okay, so
You add a 0 there.
kind of put the 0 there, just so you remember. It does exist, it's just there's 0 of them in this function. All right? But I'm holding it there just to remind myself that it's of the fourth degree. All right? Now, when you got here, you guys remember the process from here with the long division stuff?
Yeah.
What?
Actually, no, I can't.
Gotta like
I don't remember.
think it over.
It's fun though. I like
Wait.
it.
What do you think?
How many times does x go into x to the fourth? 4.
There you go.
Both.
It's how many times this x goes into this x.
Where do you put the number on top?
Up top, just like regular long division. So if I do x to the fourth divided by x, it's x cubed. And then what you put below it is what you get when you take x cubed and multiply it by what's out there. So you get x to the fourth, right? X cubed times x is x to the fourth. X cubed times negative 2 is negative 2x cubed. And then you just do it like regular division, where you subtract those things. Right?
What did you do with the minus 2?
You multiply the x to the third times the negative 2.
That's both.
Oh, okay.
Okay? Yeah.
I was thinking you said x cubed, why would you do like x to the fourth up there?
Because x to the fourth times x gives me x to the fifth. So essentially what I'm doing here is I'm kind of figuring out what I would multiply this by to get x to the fourth.
Okay.
So it's always going to be like 1. Alright? So now, here's the thing where some people are going to screw up. You got to understand, when you stack them this way, I'm subtracting that whole thing. So it's x to the fourth minus x to the fourth, which gives me 0 x to the fourth thing. So that's the 0 there. 0x cubed minus negative 2x cubed is a positive 2 x cubed.
How?
So don't forget, subtract the negative numbers into positive. I'm subtracting.
Oh yeah, crap.
Right?
Yeah.
And then you drop down your next term. There's only 2 terms here, right? However many terms you have out here is how many you're going to drop down and look at each time. If I did have something with 3 terms, then I would add 1 more term. Okay, and then you just kind of repeat the process. You go, okay, now I'm looking at 2x cubed, and I go, all right, what would I multiply x by to get 2x cubed?
2x.
2x squared. So that 2x squared now gets kind of distributed to this whole x minus 2 part. So I got 2x squared times x, 2x cubed. All right? 2x squared times a negative 2 is a negative 4 squared. So again, if I just subtract that entire thing, that's a 0, also 0. Okay? What?
Why that wasn't even funny, guys. Why is that a 0? Oh, just kidding, I got it.
Okay. Alright, so now here's the thing. I don't have any x squareds left. So that means I'm going to move to whatever will come next, which is the
2x.
2x plus 5. Now here, I'm dropping down the plus 5, guys, because look, 2 terms here, I got to keep 2 terms there. And then I'm multiplying when I have it.
What if you only had 1 left?
That's fine. No.
I mean, would that ever happen?
No, because that would be the remainder. Alright, so now, Same thing. I got 2x here. I got an x here. What do I multiply x by to get 2x?
2.
Plus 2. So that'd be 2x minus 4. Again, subtracting that entire thing. So 2x minus 2 is 0. 5 minus negative 4 is 9. Okay? So here's what happens. I've got no more x terms. All those are gone. Right? What I have here, guys, that's your remainder. All right, so what I would expect here, if you write this out, and I say, okay, what do you get when you divide x minus 2 into x4 with my and so on. Okay, when I actually do the division, like your answer, guys, what I would want you to write, plus 2. Okay, and then for your remainder, you can just add it on. Okay, like if you said maybe remainder is 9, I wouldn't mind that. But if you write it as one big addition thing, when you add it, it's 9 over what you divide.
Would you say R9?
Yeah, that's fine. Okay? Anything you want to do, if you want to do it that way, if you want to do what you said, 9 r to the x, that's fine.
What is that? R to the x?
Remainder, it's 9 telling you it's the remainder.
Can I just do R equals 9? Like
If you do it off this side, that'd be okay with that. Or just a problem like this. With the long. Okay. Now if you had to apply for something, like if you used it for other things, that would be there are going to be times.
Yeah.
you should make a note on the top. Create a not
It would be specifically aimed towards you.
Okay, cool.
Okay, now here's the thing, guys. For this division right here, unless I specifically say use long division for a problem that would be formed exactly like this with this f of x and this g of x, unless I said it, I really doubt anyone's going to fall back and do the long division stuff. Because if you remember, you have this right here, the synthetic division, right? Which this stuff definitely
Oh, I like that. That's
only
how I
works.
Yeah.
This only works when you are dividing one polynomial by something that's of the form x minus or x plus a number. So it would have worked on the last one because that g of x that I had was just x minus 2. So it would have worked here. All right? Now, if you remember the way synthetic works, and I'll do it with like example. Okay? The polynomial that you're dividing, right? The thing, all that you look at when it says the essential parts is the coefficients. Okay? And if you remember, the way I write them is like this. I don't know. I've seen it written different ways, like the little division bar kind of thing. And at the top, I put all the coefficients for whatever's being divided. Like this is my main polynomial. So the coefficient of x squared is a 1. So I put a 1 there. Coefficient for the x is 4. And the last one's negative 8. All right, and then since I'm dividing it by x plus 3, do you remember what I actually put out here? Minus 2, right? Because it's always what would make that 0. Remember that the whole idea is what you're building up to, guys, is finding zeros anyway. And that's kind of what the synthetic is used for as you go and you start factoring this out. You're figuring out what's going to make these zeros. All right? So now, your whole process, in case you forgot, is take this one and drop it down, correct? And you multiply them, right? Negative 3 goes there, correct? Right?
Yeah.
And then 4 minus 3, 1. Right. Okay, fine. The issue is what's that? 1. That is what does that tell you? X plus 1.
X.
And the remainder is negative 11. So you can write either that, or you can write
Wait, what?
R and so on.
Why is the first one an X and the second one not?
Because when you divide, remember you're dropping that power by 1. So if I start with an x squared and I divide it by an x, that x squared is going to become x. It's always, this leading one, it's always going to be one less than what the highest power is there.
Like we always have remaining.
X squared becomes
Okay,
x,
so
y and
you're
4
dividing,
becomes
so like,
Zero then.
when you do synthetic division, you remember
So that's the whole point.
Oh yeah, that's right. It's like we got
When
remaining.
you first start to eat, like, you write down all the terms, like 1, 4, minus 2, so you have to put 0 on the first, like,
Gosh.
Say it was like x squared minus 6.
adding.
Yeah, if you
Okay,
just, if
you're
I,
repeating x
like,
squared
guys,
becomes
quiet.
x, y doesn't minus 4x becomes minus 4.
You had that, you mean?
Alright, I'll show you.
Just remember when you do this,
Times 1 is negative 2.
it would become 1, 0, negative 2. Because there's 0 x's in there, but you still have to account for it. And you would still treat it the same. Like if I divided that by this,
Well, I meant the d of x being
like that. Oh, the x word, no, you wouldn't use it like, if it was that, then go back to 1.
It's okay, I get
And do it.
it.
But with what you're doing in this stuff, you're not gonna have to worry about it because we're building up. Right, we're building up to finding zeros, so everything is gonna be of this form.
I get that.
Yeah.
Like x squared becomes x, but y
This last one
y
was
doesn't
minus
minus 4x
2.
becomes
Why
minus
did that
4.
one?
Wait, what?
For the long
Yeah, I could have done.
You could have?
I could have.
Okay.
Alright, so, oh yeah, okay, guys, look, there is one theorem I'm gonna do before I want you guys to do like, 2 problems on a classwork thing before I get to the rest of this. Alright, this is a remainder theorem. This is just an application of synthetic division. And it would work good for something where you have a polynomial that has like a lot of terms in it, with like high powers and so on. This is kind of where this would save you time in terms of evaluating if like you didn't have a calculator or you need to show all your work or something like that. Basically what it's saying is that if you take a polynomial and divide it by like what it says, x minus c, like you're evaluating at a term, like c, could be 2, could be 3, could be whatever. If you divide them out using synthetic, whatever that remainder is the value of the function at that point. Right? Such as, if I asked you, I said, look, here's my polynomial, I want you to use the remainder theorem to evaluate that. Okay? Basically what I'm saying is, that's my c. I want you to take this polynomial here and divide it by x plus c. Okay? Using essentially what I just had up there, right? Doing the synthetic. Because I wouldn't expect you to do this by long. You know, you can do synthetic, it's going to be a lot quicker. Alright? And if you do that, if I set this up, this would be 6x to the 5th. Right? 0, x to the 4th, 10x cubed, 0x squared, 1x, 1. And I'm evaluating it at -2. Whatever this number ends up being here, my remainder, that's what that equals. Okay? And if you're doing these by hand, or like if I say show all the work, I mean, it makes a lot more sense to do it this way than taking -2 and trying to do it to the 5th power by hand and stuff. If I had said no calculators or anything like that. That's where this would be applied. Okay, so if I go through my synthetic division, right, this 6 drops down here, correct? Okay, -12, 24, correct? 34 times -2. -68.
Oh, God.
Negative 68 times 2.
I just said okay, first, 36 and 66.
So 137 times 2. 4. Negative 270. That'd be your answer. So that equals negative 273. That's how it works. You do, when I say use the remainder theorem, essentially what I'm saying is do synthetic division. Whatever your remainder is, that's the answer. Okay? That's kind of what the theorem is. Like if you read through the theorem, normally see it done that way, you know, it's just kind of, like if I just left it at them, they're like, yeah, have fun with that. You probably wouldn't know what the heck I'm talking about. Okay? But it is simply just, when I do this, it's just another way for you to practice doing some synthetic division stuff. It's given at least one application to it right now.
Wait, so what is the negative 273?
So that'd be the
This
answer.
is, like, I know if I took negative 2, plugged it in here, I would get negative 272.
Oh, yeah.
But like I said, the only way this would really be a viable option for you is if I gave you a test and I had like high powers like this, and I said, don't even calculate it and evaluate it. Like if I did maybe P of 4, I wouldn't expect you to sit down by hand and do 4 to the 5th power times 6 plus 4 to the 3rd power times 10. I would just expect you to come over here and use synthetic. But if I gave you like a calculator, like if you have that available, which you will, I'll tell you to use this here. But the only reason this would come up is if we're not allowed to use the calculator. Okay? It's simply for evaluating the function, that's all. All right? Okay, now, here's what I want you to now, and here's the thing, with this talks about you having to do all the factors for a specific constant. The easiest ones with this will be ones that have a leading term or leading coefficient of 1. Okay, because then everything's going to be over 1. Because Q, the P over Q is telling you what numbers will be a possibility. So if you put it over 1, guys, that means that everything's divided by 1, which are just your regular old, what you consider whole numbers, integers. The problem comes when you've got a different leading coefficient, like if your leading coefficient was 3 or something, then you'd be dividing numbers by 3, which means you might have fractions for possible zeros. And guys, with these, when we go through finding zeros, if fractions come up, you got to deal with it. They got to have. I need exact answers here for your zeros. The zeros are your solutions. Okay? Yeah.
So like possible zeros and possible solutions.
Yes. And what this is doing, like as we go through it, it's building up to, I'm going to give you a polynomial, say find all the real zeros. All right? And this part right here just gives you the numbers to check in synthetic division. Because essentially it's going all back to you checking numbers in synthetic division. All right? Now, just for problems like this, I would give you maybe that. I'd say, look, here's a polynomial. I'll go back later if you got to remind me later. All right, where I say, look, here's a polynomial. Find all the possible rational zeros of this. Okay, and that's kind of what it's saying. Even though they just say find the rationals, which is what the directions will say. It's saying find all possible values. All right, so essentially what they're doing is they're asking you to find every possibility of P over Q according to that theorem. Okay, the rational zeros. All right, P is all the factors of that number, the factors. Right. P is the factors of that -4. All right, up here that coefficient there is 1. So the Q is going to be all the factors of 1. Okay, which I said these are easier because all the factors of 1 are plus or minus 1. So it means everything you do here is going to be divided. All right, so first thing I'm going to do is I would list out what P and Q are. All right, so if if the leading coefficient is 1, all my factors of 1 are plus or minus 1, like I already said. Okay? For P right there, factors of -4.
Blocking my view.
What are your factors of -4?
1.
Minus 1, minus 4, plus minus 2. All right, so you've got, I mean, essentially if you take into account that you're doing plus or minus, you've got 8 numbers up there. Okay, so that means any combination of these would count as a real zero if I put P value on top and Q on the bottom. Such as if I did if I just go one by one, my p-values could be a positive 1 or a negative 1. My q-values could be a positive 1 or a negative 1, or I could have that, or I could have any combination of them. So what happens is, if I wrote out every single possibility, I would have a lot of numbers to pick from. But if you're doing this, you can kind of use a little bit of your reasoning here. I mean, you would understand that these numbers are on top of my fraction, 1's on the bottom. All these divided by 1 are still -1, 4, and 2, correct? Like 4 divided by 1 is still 4. 2 divided by 1 is still 2. So I know that all my possible values for this right here are 1. Okay, this right here would be your final answer. I don't need to. The only time I'm going to need to actually sit down and write out all of them is if this q was something other than 1. Okay? And if it was a 2, then I would go through all my different possible values. Okay, because then I'd have numbers divided by 2, and so on. And you only listed 1, so you're going to have a lot of these things that overlap. Okay, like there would have been, if I listed out every single possible combination of positive and negative, I would have had positive 1 in there twice, negatives in there twice, so on. Okay? So all this is asking you is find the possible values. All right, now, the way you're going to apply this, right, is now you're going to take this. If I said find the zeros of this, then you would take these numbers right here, okay, and you can either plug them right in. If I took these numbers like plus or minus 1, 2, and so on, and plugged them in, whichever one equals 0, my zeros. Or if it was something with like very high powers, I would switch back to doing synthetic division. Okay? I would take my synthetic and just use these numbers for your synthetic division part. Like I would pick a 1 on the outside, a 2, 4, and so on. Yeah.
Where did you get Q from?
This number in front.
And so for any number you get, you always make it plus or minus?
Because it's backwards. The positive 1 and negative 1 can divide into it. It's always going to be plus or minus. Right. All right. Now, next thing, okay? The next part here, guys, the Descartes rule of sign.
This content.
This. What this one basically does is it allows you to kind of figure out all the possible positive zeros or negative and real zeros, I should say, sorry. Positive real zeros and negative real zeros for a specific polynomial. Now, it reads really odd, okay? The whole switch in sign thing, the variations in sign, that's not a big deal. Because that just means it changes from a positive to a negative. But the whole less than an even whole number thing, that usually throws people. Even whole number, guys, is like 2, 4, so on. So if you had like 3 sign changes, like let's say for the first one, I looked at my polynomial that's there. There were 3 sign changes between my coefficients. That means that there's a possibility of having 3 real positive zeros or 1 positive zero. This is a very vague thing, but when we get to problems where you have to find out all of the real zeros, or even all of the zeros when we start including the imaginaries in there, this will help out a bit. Because then you'll know where you can stop with the real zeros, where you need to get to in terms of real zeros. So, okay, probably not going to be applied as much today. This is more when we get to, did we write all this down? Let me do the example real time.
Write all of it down right now.
Example would work better. Because you could read these words over and over again. Talk about words. Yeah.
Okay, when it says equal to the number of variations, so it started off like x of 5, and then it went to x of 4, then, x to the 5th, and then x to the 4th, that would be a variation?
No. This is
No.
talking about positive and negative. If you said x to the fifth plus x to the fourth, those are both positive.
Oh.
Positive x to the fifth, positive x.
Okay, but if we were to go to like,
If we went to x to the fifth minus x to the fourth, then that would be here.
and then back to like
Up
plus
above.
x to the third, what if it was like plus x to the second after that? You have to account.
Then that
for-
wouldn't count. Anytime it's variation. If you have
Right, but I
like,
mean, if it was like positive, if it was like x to the fifth minus x to the fourth plus x squared.
then yeah, that would count.
So that's just.
Even if there's a gap in between.
Okay, and, you said, like, you gave an example and you said if there was like 3 variations, or there was 1, but I thought it was also an even whole number.
Because, all right, let's just say for example, like I said, I was checking this.
Oh,
Yeah.
you subtract, okay.
Yeah, so if I said, look, there were 3 sign changes in it,
Mhm.
that would mean that there is a possibility of having 3 positive real zeros. But then you have to say, well, since 3 is bigger than an even whole number, like gap, like I can't go beyond 0, obviously. Then you just subtract. It's all a matter of subtracting 2 each time. I mean, if I had 5 sign changes, then it'd be 5, 3, or 1. Okay?
Okay.
All right, so like, just for example, guys, what this would look like. So there's my p of x, my polynomial. And I just asked you, look at it, just tell me what is the possibility for positive and negative real zeros. I'm not asking you what the actual zeros are. I'm not asking you to make a definite determination of how many there are. I'm just saying list all the possibilities for just how many could exist. Okay, so I'm not going to put a definite term on, there's going to be 3 here, or 5 there, or whatever. Okay, now for the positive one, okay, for the positive real zeros, all right, for the amount of them, I'm just going to look at the signs for the original. Like the first number here, that's a 2, it's a positive 2. The next one's a negative 1, then a positive 4, then a negative 7. So if I look at that, I go, okay, I've got one variation here, right? We're going to go from positive to negative. Another variation there. And I got one more. So in all, there's a total of 3 sign changes. All right? And what that tells me, according to the Descartes rule of sign, is that since the original has 3 sign changes, that means that for my positive reals, there is a possibility of me having 3 positive real zeros or 1. Okay? I can't, by just looking at the sign changes, I can't make a definite determination between them. All right? I just know that there is a possibility for having them. Now, like I said, this is going to come more into play when we start throwing the all zeros in there, including your complex ones and your real ones. Right? Now, for the negative ones, what you need to do, all right? For the negative, it says, look, rewrite this so that you're plugging in a negative x and basically create a new polynomial. All right? Such as, take this, the original, plug in a negative x, and then simplify it. Right? Such as, if I do negative x cubed, if I cube a negative number, is it still negative? Yeah, like negative 2 cubed is negative 8. All right? So if I simplify this, this actually becomes negative 2x cubed. If I square a negative number, is it positive or negative? Positive. So I know negative x squared is actually just x squared. Negative x doesn't change, so that becomes negative 4x minus 7. Okay? So now, when I do this step, now I can say how many negative real zeros there are. All right? By looking at the sign changes here. If I look through them, that's negative, negative, negative. I don't have any sign changes here. So I know for a fact that I don't have any negative real zeros. All right, and see, now that would be beneficial today because like the thing before this, with the rational theorem, the rational zero theorem, said like, you know, I have all my possibilities of zeros, which with the one I had up there were like plus or minus 4, plus or minus 2, plus or minus 1. But if I do this and I say that there aren't any negative real zeros, I can throw out the minus part. Like then that would change my possible zeros down to just 1, 4, or 2. All right, as opposed to plus or minus. So this does have benefits to a point with the stuff we're doing today. Okay, you just have to put it in the context of each problem. All right. Now, all this stuff together. Okay, everything's together. Whoa.
Let me go next door. I will pay you to let me go next door.
Was that Simpsons?
Yes.
Oh my God. Wait, didn't they just get their test back?
I just want to say thank you for being the SL teacher.
Yeah.
Thank you so much.
Oh my God.
You saved
I
me.
have friends in that class. Really over there getting work.
Have you ever been known to be abusive other than verbally abusive?
I thought it was a movie, then I realized it was him.
All right, yeah.
I mean, he has a problem. That's a
Who's
problem.
gonna switch out by tomorrow, right?
I just am so happy. Cortina's gonna switch up then.
Poor little
You
Cortina.
can't take that imagine that would have been being screamed at. Are you
Poor
serious?
little kid.
What is
All right, yeah.
Daniel's like,
Quiet. Okay, so look, everything that was up there, right? I said it's all built up to you guys finding basically the real zeros. All right, just look up rational. But you're looking strictly at reals because I don't have any imaginary stuff right now that we're dealing with. In order to do this, okay, like essentially you're using everything that was up there. You're doing synthetic, you're doing the possible zeros, everything. Okay, now, the step 1, when it says list possible zeros, you can actually do a combination of the Descartes rule of sign changes. Okay, figuring out how many possibles there are, along with that first theorem that said these are the possible numbers that could be a rational zero, with the whole P over Q thing. All right, so step 1 kind of involves both of them. For the things today, you don't necessarily have to do the Descartes rule. Okay, that'll benefit you more, like I said, when we get to the imaginary. But you know, it might be a good thing because you can kind of do it in your head. That if you look at it, you know, you might be able to eliminate some of the possible zeros by doing the rule of sign, the sign change thing. All right, but essentially it is find the zeros, use those zeros, the possible ones, for synthetic division. And you always want to have those list of zeros because you don't want to just start picking random numbers to try and divide into a polynomial with the synthetic. You want like a set thing to pull from. Okay? And essentially what you do is you keep it going until you get down to something that's like x squared, where you've got basically 3 numbers left on your synthetic division. Because once you've got 3 things left, just 3 terms, all right, you're down to a quadratic. And once you're there, you can either factor it out or just do quadratic equation. Okay, the quadratic formula. Okay, so once you get to that step, you're either going to be able to factor it or you're going to be able to do quadratic formula.
All right.
Okay? All right, I'm going to do one problem with all these. Okay, all the way through, and then that's it. Okay? Blah, blah, blah. It was. Okay, so this is the one we're going to do. Finding all the real zeros. Again, we're not dealing with imaginaries right now. Okay? That'll come eventually. All right, and this one's actually not that bad because of the fact that the last coefficient is 2, so there aren't many possibilities for zeros. Okay, so first step would be I want to find out all the possible zeros that could be. Such as going through it like this V or P, right? All the factors of 2 would be become the b, which are plus or minus 1, plus or minus 2, correct? All right, and again, leading coefficient there is 1, so I know my q part is plus or minus 1. Which, since that leading coefficient is just plus or minus 1, that automatically makes that all my possible zeros. Because I don't have anything divided by it. Yeah. Okay, so I know right now that just looking at that first step, doing the P over Q part, I know P over Q, right, tells me all my possible zeros, which are going to be plus or minus 1 or plus or minus 2. Yeah.
So you're getting your P from the last,
Factors of this number.
okay, so the factors of the last over 1.
Yes, the number.
The constant. Not a.
Okay, now, again, the whole point of having these here, so that when you set up synthetic division part, which would be 1, 2, -2, -3, and 2. The whole point is now when I start picking numbers out here, because I don't know exactly what numbers to pick, I just want the zeros, I'm simply choosing from those 4 numbers there. +1, -1, +2, negative. Okay? So I don't really care which ones to pick. Like,
Go with 2.
2?
Yeah.
Alright, so I'll start with the 2. Alright, so if I start with 2, I get 1, 2, correct?
Yeah.
4, 8. 8 minus 2 is
6.
6. Well, is that one going to work? Like, if I keep going, am I going to get a remainder here?
Yeah, you're
Yeah, if I keep going, I'm going to get a remainder, so that one doesn't work. So that one's scratched. So we're actually now down to 3, 0. So +1, -1, or -2. All right, which one do you want to try next? Maybe 1. All right, so if I try 1, I got 1, 3, 1, -2, -2. Hey, so that's one. So I know one of the real zeros is x equals 1. Okay? All right, now, I've got 4 numbers there, so that means I'm not yet to a quadratic, right? Okay, so I got to keep going. So now I've got -1 and -2 to pick from. Which one? Negative what? -2? -2. So 1, 2, -1, 2, 0. Does that work? Right? So my only other option here, honestly, is -1, using all the possibles. What I would probably do, since I only have one other option, I wouldn't even bother. Like, if I had more than one option here, guys, what I would do is I would take that, right, as x squared plus x minus 1, right, and then factor it out. But since I've only got one more option here, which is -1, I'm just going to go ahead and do synthetic. Since I've only got one more thing to try. Okay? Like, see here, my reasoning here is from all the choices I got down to where I only have one more option, right? So all I'm going to do is I'm going to take that -1 and do one more synthetic. If I had like 3 more to pick from, then what I would do is I would take this right as the quadratic that it is, and then probably do like quadratic formula.
Only to make you choose faster.
Yeah, or like I said, or
Could
factor.
you just keep synthetic divisioning it?
Yeah, you could. Because the problem is, you've got like, say, you're gonna have time when there's like 4 more options. You don't want to sit there and try one thing. It's a lot, because you have quick things to solve quadratics with. There's no point in wasting time. All right, so here's the thing, guys. If I tried this, does this work as a 0? No. So these are my only options here. So the answer for this, all the real zeros are these 2. All right? Which coincidentally also means that there are 2 imaginary zeros because it's to the 4th power and I need 4 zeros. All right? But we're not dealing with imaginary yet.
How did you know what numbers to start with? Like you started with a 1 and then took the result of that and did -2, but how do you know to start with 1?
I just picked that. It's a trial and error. You could probably get about halfway through each one. There's gonna be times when you're not gonna be, like, you might try 2 of them, you might not have a result, so you just have to keep going. It's easier to pick small numbers first.
So like,
And honestly, like, when you guys told me to do positive 2 the first one, I could have got probably to about the 3rd row here, and I knew it wasn't gonna work. Like, because I could see the number was getting too big, and there's no way it would wash out to a 0 right here. So I would just stop. There's no way it's gonna work. I'd move on to the next one. And you just have to get used to doing it. Okay? Alright, so.
Whoa.